In section 1.3, we're talking about midpoint and distance formulas. This is actually something that we discussed right at the end of the year in algebra, but it's really important for geometry. We're going to talk about some of the aspects of midpoint and distance formula with geometric figures. Talking about midpoint in general, in geometry, the midpoint, think point in the middle, it really is the point in the middle. It's the point of a segment that bisects a segment into two congruent segments. This term bisect you're going to see over and over again this year. Bisect, if you think about in your science classes, if you're going to dissect, and I know you guys dissect like worms or frogs or whatever it might be, but dissect means cutting apart, right? Well, if you're bisecting, you're cutting apart into two parts. That prefix bi means two parts or two things. So we're cutting into two parts, but the important thing about those two parts is that they are congruent. So really, that word bisect always means cut in half. So if there's something that you can associate with the word bisect, think cutting into two parts, but those two parts are congruent. So bisect always means cut in half. So midpoint does just that. It bisects or cuts in half a segment into two congruent segments. So if I knew that for segment AB here, if I knew M was the midpoint, it literally is in the exact middle. It cuts that segment in half, meaning that from A to M is the same distance or a congruent segment with MB. Now if you remember back from the last section how to mark segments congruent, you do the same number of tick marks. If I put a tick mark in AM and in MB, I now have shown, visually, I guess, indicated that these segments are congruent. So I could say that segment AM, remember with line segment, put your line segment over the top, is congruent to line segment MB. And that would indicate that for sure M is the midpoint. It bisected or cut in half into two congruent parts this segment. Without this visual tick marks, you don't know anything unless it's told to you that M is a midpoint. With these two tick marks, you know for sure M is a midpoint, and you know for sure that line segment AM is congruent to line segment MB. With that term bisect, you can have an object that's the actual physical bisector. It's the thing doing the action. It's the thing that actually does the cutting in half. So a bisector could be a point. Like here, the bisector is point M. It's the thing that cuts in half. It could be a line going through at point M. It could be a ray with one arrow. It could be a line segment. It could be a plane. It could be a flat surface cutting through at M. But a bisector is anything that intersects. Remember that intersects means crosses or meets this segment at its midpoint. So anything that would be going through at M, whether it was a line, whether it was a ray, and going in any direction, would be the bisector. Okay, whoops. I was going to write a bisector is the actual object or the thing that cuts something in half. Geometric object, again, point, line, ray, line segment. The object that cuts in half another is the bisector. An example of this, if you were told in this pentagon is a five-sided figure, line segment ST, which is here, bisects line segment MN at point P. So if it says ST bisects MN, that means ST, remember what does bisect mean? It means cuts in half, two parts that are congruent. So ST does the cutting in half of MN. MN is the thing being cut in half. ST is the thing that does the cutting in half. So ST is the thing that cuts in half. It cut MN in half at point P. So P is called the what? The midpoint of MN. Now it's the midpoint of MN because this is the thing that was bisected. Is P the midpoint of ST? I don't know that. ST was the one that does the cutting in half. It cut in half M to N. Now, you should also know, if I told you to put something on this figure that would indicate to me that P is a midpoint, you would say, well, I'm going to put a tick mark on MP and PN because now I know that MP is congruent to PN. Those segments are congruent. Their lengths are equal. P is a midpoint. Let's see what I'm figuring out here. If line segment PN, notice without this segment above it, we're talking about the length. So P to N is 7.8. I want to find MN. Well, MN is this entire segment, which if this is 7.8, so is MP, because again, P was a midpoint. So MN either equals 2 times 7.8 or 7.8 plus 7.8. Either way, I find that MN is 15.6. Okay? Let's talk about the word bisect and midpoint there. Another example using some algebra. Point S is the midpoint of line segment RT. Point S is the midpoint of line segment RT. S is in the middle. It is the bisector of line segment RT. It cuts RT in half. Again, if I said, can you put something on this picture that would indicate that to me? You should say, well, if I put the same number of tick marks on RS and ST, now I know that S is the midpoint because now I know segments RS and ST are congruent because of those tick marks. Eventually, I'm supposed to find ST. I'm supposed to find that length. Remember, without the sigma, we're talking about the actual length or the number associated with the distance from S to T. Well, I'm not going to be able to find that unless I find X. The good news is, what do I know about 5x minus 2 and 3x plus 8? Or what do I know about RS and ST? Well, they're congruent. Their lengths are the same. They're equal. So if they're congruent, they're also equal. Their lengths are the same. So I can take this 5x minus 2 and I can set it equal to 3x plus 8. Again, how did I know that? Because if S is the midpoint, I knew that line segment RS was congruent to line segment ST, and if those segments are congruent, then their lengths are also equal. So I'm setting those equal. Now it's some algebra. I have variables on both sides. I would probably subtract 3x from both sides first, and now I have 2x minus 2 equals just 8, right? Subtract 3x from both sides. Add 2, 2x equals 10, and x equals 5. Notice I wanted to find ST. ST was 3x plus 8, so 3 times, what is x? 5. Plus 8, 3 times 5 is 15, and 15 plus 8, it looks like ST is 23. Hey, I better make sure that I got the right x. If I plug that back in, this better be 23 as well, so I plug in 5. 5 times 5 is 25. 25 minus 2? Yep, 23. So since S was a midpoint, those segments were congruent. The next thing we're looking at is midpoint formula for the actual coordinate plane. We talked about this last year, so hopefully this will be familiar. If I have points A and B on a coordinate plane, again, every point's written x, comma, y. Point A, I just put little sub 1 because it'll be the first point. And point B, I just put little sub 2 because it's my second point I'm talking about. So here's point A. Here I'll put point B. Again, let's just call A my first point, so x sub 1, y sub 1, and call B my second point, x sub 2, y sub 2. If I want to find the midpoint, you know that the midpoint is literally in the middle. It bisects, it cuts it in half. If this is a midpoint, we'll call it M. I need to find the new coordinates of that midpoint. Now, every point's written x comma y, right? Well, think about this for a second. What directions does x go on a graph? X goes left and right. Isn't this exactly in the middle of the left and right movement of A and B? I mean, this is how far to the left A was. And this is how far to the right B was. The x's are in the exact middle of this x and this x. Because again, x is how far left or right. And isn't the y going to be exactly in the middle of, well, y goes up and down, right? This is how high up point B went. This is how low point A went. Shouldn't it be exactly in the middle, up and down as well? So the real question is, how do you find the middle or the average of two numbers? Because the midpoint is just a new point. And we know every point is written x comma y. But since it's the midpoint, it's in the middle. It's in the middle of this x and this x sub 1 and x sub 2, the first x and the second x. How do you find the middle of two numbers? How do you find the average of two numbers? You add, divide by 2, right? So shouldn't I take the first x and the second x, the x of the A point and the x of the B point, add them and divide by 2. That'll be the new x of my midpoint because it's in the middle of the left and right movement. And what about the y of the midpoint? Shouldn't it be the middle of the y from the A, which was y sub 1, and the y from the B, which was y sub 2, and to find the middle, you add two things and you divide by 2. This is all there is to the midpoint. You add x's, divide by 2. That'll give you the middle of the left and right movement. You add the y's, divide by 2. That'll give you the middle of the up and down movement, and you've got your midpoint. So let's try this out on an example. The endpoints of line segment RS are, R is at 1, negative 3, and S is at 4, 2. Find the coordinates of the midpoint. Well, if those are the segment endpoints, and I want to find the midpoint, I know that I should find the middle of the x's and the middle of the y's, and to find the middle of the x's, I'm going to add the x's and divide by 2. Here's the x of this point, 1, and the x of this point is 4. So I'm going to add 1 and 4 and divide by 2. And to find the middle of the y's, I'm going to add the y's, which are negative 3 and 2, and divide by 2. So I'm going to add negative 3 and 2, those are the y values, and divide by 2. Looks like the midpoint is at, well, 1 plus 4 is 5 divided by 2. And negative 3 plus 2 would be negative 1 divided by 2. I can leave it as 5 halves, negative 1 half. I can go to a decimal if I want. 5 halves would be 2.5. 1, negative 1 half would be negative 0.5. So either way would be fine. This example 4 is probably the trickier one today. Maybe trickiest example today. The midpoint of line segment JK is at, and M for midpoint, 2, 1. Now one endpoint is J is at 1, 4. I need to find the coordinates of endpoint K. So I have the midpoint right now. I know that if I add the x's divided by 2, I get 2. And I know if I add the y's of J and K divided by 2, I get 1. I have the midpoint. I don't know endpoint K, which means I'm looking for the x, y of point K. I don't know what it is. And maybe I'll call it the x sub 2, y sub 2, since I have the first point. Point J was at 1, 4. This is the midpoint. This is the middle, is 2 and 1. So let's see. What do I know that I do to get midpoint? Don't you add x's and divide by 2? And don't you add y's, divide by 2? So I'm thinking, let's start out and just think about x's. I would add the x's, divide by 2. What is the x? This is an endpoint, right? I don't know the other endpoint. So one endpoint was 1. The other endpoint is, I don't know, x sub 2. But I know that if I would add the two x's of the endpoints of j and k, and I divided by 2, I would get, here, I'll say that I'm dealing with x's right now. Okay, but I know if I add the endpoints 1 and unknown, and I divide by 2, I get the midpoint x, and the midpoint of the x is 2. I'm going to have to solve this for the other endpoint. Now this is all being divided by 2, so I'm going to multiply by 2. And I get 1 plus this x sub 2 equals 2 times 2 is 4. I subtract 1, and it looks like x sub 2 is 3. Okay. Let's deal with the y's. I know to get this midpoint y, I had to add the y's divided by 2. The y of one endpoint is 4. The y of the other endpoint, I don't know. Y sub 2. But I know that if I add divide by 2, I get the middle of the y's, which is 1. And again, I have to solve for that other endpoint, so multiply by 2. I get 4 plus y sub 2 equals 1 times 2 is just 2. And I subtract 4. It looks like y sub 2 is negative 2. And now that I know that the x sub 2 is 3, and the y sub 2 is negative 2, I can find the coordinates of that point K. X comma y is 3, comma negative 2. And you know what? Let's check and make sure this makes sense. My endpoints were 1, 4, and 3, 2. I want to see if that's in the middle. Now, is 2 in the middle of 1? and 3? Yes, it is. Is 1 in the middle of 4 and negative 2? Yep, that looks right. So you know you've done it correctly. Okay, for this situation, if you have the endpoint, you need the midpoint, I would set it up separately, look at the x's, add the x's divided by 2, and equals the midpoint x. Add the y's divided by 2, equals the midpoint of the y. And solve that way. The other thing we're looking at today is distance formula in a coordinate plane. Again, I have 2 points, A and B, and A is going to get those coordinates of x sub 1, y sub 1, because it's our first point. And B is going to get the coordinates of x sub 2, y sub 2, because it's our second point. I need to find the distance. I want to know how long is this line segment between A and B. If you remember, we did this last year, and it's actually an extension of Pythagorean theorem. And hopefully Pythagorean theorem brings to mind right triangles. Pythagorean theorem uses the fact that the hypotenuse squared of a right triangle equals one leg squared plus the other leg squared. Now when we talk about right triangles, we better have a right triangle, huh? So I'm going to go just left and right for one leg, just up and down for the other leg. Now this distance becomes my hypotenuse of my right triangle. So I know that the distance between A and B squared is one leg squared, which is here, plus the other leg squared. Thing is, I have to come up with what is the distance of each leg. Now this is moving which directions for this leg? This leg is moving horizontal, left and right. What variable does left and right? X. And to figure out how far I'm going from one x to the other, if you think back to ruler postulate in the last section, we know that from x sub 1 to x sub 2, why am I talking about x's? Because we're going left and right. All I do is I would take whatever the distance is at x sub 2 and subtract whatever the distance is at x sub 1. For instance, if this point was out at 6, if B was at 6, and this was at 1, I know the distance was 5, because I would do 6 minus 1. So this leg is x sub 2 minus x sub 1. What's this leg? This leg is vertical. It goes up and down, and what variable goes up and down is y. If I want to know how high this is from one to the other, I take the y of the second minus the y of the first. Again, for instance, if B was up at 10 and A was at 3, I would do 10 minus 3 and get 7. Okay. So in this case, the hypotenuse squared, which is really the distance I want, so instead of hypotenuse, I'm going to put distance squared, equals one leg, which is x sub 2 minus x sub 1. Now this whole quantity needs to be squared, so I'm going to put parentheses there. Plus the other leg is the up and down, which was y sub 2 minus y sub 1. Again, that quantity needs to be squared, so I'm going to put parentheses. Except for I want the actual distance, not distance squared, and how do you undo squared? You take the square root to undo squared, so I take the square root of all of this, and this is the distance formula. In the coordinate plane, if you want distance, you take one leg, which is left to right, x sub 2 minus x sub 1. You subtract and you square that. Then you add the other leg, which would be up and down, which is y sub 2 minus y sub 1. That quantity squared. Take the square root of all that because it's hypotenuse squared, and you've got your distance. So let's give distance formula a shot on an example. What is the length of line segment RS with these endpoints? I need the length, I need distance formula. So I know distance equals, I'm going to be doing big square root, I'm going to be subtracting x's, squaring that, I'm going to be subtracting y's and squaring that. Okay. Oh, by the way, you can subtract in any order because we're squaring this quantity, and whichever order you subtract, you're just going to get a positive or negative of the same absolute value. And when you square, you know you get positive, right? Because even if it's a negative squared is a negative times a negative or positive. So it wouldn't matter what way we subtract the x's, just make sure you pick the x's. So here in x is 2 minus, make sure you subtract the other x, which is 4. Quantity squared plus, now I'm going to make sure I subtract the y's and square it. The y here is 3. Minus, the y of this point is negative 1. Notice I'm subtracting a negative 1 here, so I'm really adding 1. Here I have square root of 2 minus 4 is negative 2. Quantity squared, really it doesn't matter, it's a negative 2. because I know I'm squaring it, it should turn positive. This turned to 3 plus 1, so really that's 4 squared. Negative 2 squared is just positive 4. 4 squared is 16. It looks like my distance is the square root of 20. 4 plus 16 is 20. I guess a few ways to get this answer here. Either we do actual square root on the calculator, because I know 20 is not a perfect square, and I could get an approximation as a decimal, which the approximations, I'm not going to do an actual equal sign, I'm going to squiggle because it's close, 4.47 about. Or I could get my exact answer. If you think back to last year when we worked with square roots, you think, is there a perfect square factor of 20? Does anything multiply into 20 that's a perfect square? And you might think of 4, and you could break down 20 as the square root of 4 times 5. Because 4 times 5 is 20, but I know the square root of 4. The square root of 4 is 2, so that can come out of there. So 2 square root of 5 would be the exact answer there, 4.47, a decimal approximation, so either answer is okay with me for the distance. So today, talking about midpoint, talking about bisecting segments, talking about how midpoint creates congruent segments, and using distance formula.